All right, so now we've got an idea of what the PGF is, right? What we can create one, right? We're not quite sure exactly what it does or why we need it yet. Hopefully that's what I'm going to accomplish in this video and the next one as well, as we look at the two reasons that we have for using PGFs. All right, I'm not going to go deeply into the theory of why it works or algebraic proof of anything. If you want that, you can probably find it on Wikipedia or in your textbook, but at this point in our mathematics careers, it's not super important that we go through all of the why it actually works, okay? And it's not important for the exam either, okay? So I'm not going to go into that too much, but we are going to go into, okay, now that we've got this, what exactly can we do with it? All right, so we're going to consider a discrete random variable with values, natural values, all right? So what that means is, of course, that g of t is equal to p0, t to the 0 power, plus p1, t to the 1, plus p2, t2, on and on and on as far as we need to go. All right, so I want us to go through a couple of different things. First, can we find out what is g1? Okay, so we're going to do g of 1. So this is putting 1 into the t value for the PGF, all right? And this is going to give us p0 plus p1 times, this will be 1, plus p2, this will be 1, all the way up to however far we go. Now, what do we get if we add all those probabilities together? Well, when we add all the probabilities together, we should get 1. So that's snazzy. All right, interesting. Why does it happen? Okay, well, it does because when t is 1, the t's go away, so all we're doing is adding the probabilities together. That should, in a way, kind of make sense. All right? Now, next thing I want to do is let's find the derivative of g of t. All right? So the next step in our exploration here is that we're going to do g prime of t. All right? So let's do that. The derivative of a constant, a probability, would be 0. Okay? The next one, we're going to bring the 1 in front, right? Meaning that's going to be p1, right? And then the t will be to the 0 power. And keep going with that. Then we'll have plus, bring the 2 in front, so 2, p2, t, and so on and so forth. If we do this in a more general fashion, right, then what it'll end up being is that it'll be the summation from k equals 0 up to infinity of, remember it was pk t to the k, right? This is equal to pk t to the k. So what I'm doing when I do the derivative is the k is coming in front, giving me k, pk, and then I'm doing t to the k minus 1, right? So that's really what's happening when I take the derivative. So this right here is the derivative, all right? The next step is I want to do g prime of 1, which means I'm going to put 1 in for the t, and what I get is the summation from k equals 0 to infinity of k p to the k. Does that look familiar to you? It should, because this is the expected value. Now, that may not be shocking at first, but recognize that we did this for a discrete random variable. That means for any probability distribution. This could be for a binomial distribution or a geometric distribution or a negative binomial. All those different discrete random variables, all of those distributions, if I take the derivative of the PGF and then put 1 in for t, I get the expected value. And that's one of the things that you're going to be doing in your practice tonight is you'll start with a PGF, or you'll create a PGF, you'll take the derivative, and then you'll put 1 in for t, and that will give you a function that will give you the expected value based off of the probabilities. Pretty cool, huh? Anyway, so let's extend this a little bit further. Why? Because we can. So naturally, the next step, the next thing I'm going to ask you to do is, well, let's find out what G double prime of T is. Okay, so G double prime of T means that I'm going to be taking the derivative of this right here. Okay, and so I'm going to be getting the summation from k equals 0 up to infinity. It'll be k times k minus 1 times pk t to the k minus 2, right? Because I'm bringing that k minus 1 in front, I'm subtracting 1 more from it, and that's what I get. Okay, now if we take that, and again, we're going to do G double prime of 1, and we then get the summation from k equals 0 to infinity of k times k minus 1 times pk, because this right here is going to be 1 when I put 1 in for t. All right? Now that I've done that, I want you to think about that, okay? So what this is it's the summation of some value times the probability of k. All right, so what we've got here then is the expected value, oh, sorry, not that one. We've got the expected value of k times k minus 1, or in other words, k squared minus k, right? Now, using the stuff that you guys learned in that first unit in section A, that means this is the same thing as the expected value of k squared minus the expected value of k, right? Now, we learned when we were learning about discrete probabilities, right? When we did the expected value and variance and all those things, that the variance of x is equal to the expected value of, x squared. You can look at your formula packet for this if you'd like. Expected value of x squared minus the expected value of x squared. All right, now let's put together all of these things that we've just done, right? So we found that g of 1 was 1. We found that g prime of 1 was the expected value. We found that g double prime of 1 was e of x squared minus ex. So if we put all of these things together, right, then this right here, e to the x squared, let's leave that for a moment, okay? We're now going to try to get this to match what I have here, right? I know that g double prime of 1 is ek squared minus ek, or ex squared minus ex. So I need a minus e to the x here. So what I'm going to do is I'm just going to rewrite it. I'm going to say the variance of x is equal to e to the x squared. Then I'm going to put in a minus e to the x, but of course if I put in a minus to the x, I got to put a plus e to the x there to balance it out. Just add and subtract the same number, and then minus the ex squared. Now, putting all that together, right, I now have e to the x squared minus e to the x, which was g double prime of 1. Okay, so now I know that the variance of x is equal to g double prime of 1 plus the expected value of x, which is g prime of 1, minus the expected value of x squared. So that would be g prime of 1 squared. Now, you may not recognize how significant that is right now, but remember we had all this stuff before that had all these sigmas and things where it was very difficult. It's very difficult to calculate a sigma by hand if it's not a simple arithmetic or geometric distribution, sequence, sorry. So we're being able to avoid these summations now because we're now saying, well, if I can take the derivative of that and put a 1 into it so that I have certain values, then I should be able to use the PGF and only the PGF, because this is the derivative of the PGF and the second derivative of the PGF. I can use the PGF and its derivatives in order to calculate the variance of a distribution. All right? And so we're actually going to look at that in the next question that I've got here. Okay? In the next question, we'll go ahead and look at a specific situation, but that's what you're going to be doing for homework tonight, is recognizing how we can use all of those things in order to calculate expected values and variances of different types of distributions. All right? So, let's go ahead to the next slide and see how it works. All right? So here we have a discrete uniform distribution with values 1, 2, and so on and so forth. All right? And we're going to go all the way up to n. And then we're going to say that x has PGF, and this is a PGF that you proved before, right? So I'm going to go ahead and write that here just because it's easier for my brain if I put down what I know I'm going to be using. So g of t equals 1 over n times t plus t squared all the way up to tn. All right, I'm going to use the PGF and differentiation to prove the expected value and the variance. Okay? So the first thing I'm going to do is I'm going to find g prime of t. Okay, the derivative of the PGF. So the constant is going to stay the same. Then I need to take the derivative of everything inside. So that's going to be 1 plus 2t plus, and then the next one would be 3t squared, all the way up to nt to the n minus 1. Right? Okay, now I'm going to go ahead and put in the 1. And you, at first, the thought is, yeah, but how am I going to work with all that? Well, the reality, remember, is that you don't have to work with all that, because what we need is the first derivative of 1. And so it'll be 1 over n times 1 plus, oh look, if I put a 1 in for t, then I get 2. Plus, put a 1 in, now I got 3, all the way up to n, right? And this is a arithmetic sequence, or series, sorry, because I'm adding them together. All right, so I can do the addition of that, okay, because I have a first term of 1, I have a constant difference of 1, or common difference, and then I know that the number of terms is n. So I'm going to go and I'm going to solve that. I'm going to say, well, that means that g prime of 1 must be equal to 1 over n, and then put this into your arithmetic series, n times n plus 1 over 2, right? Simplify this, 1 over n and the n cancel out, and I've now shown that g prime of 1, which, by the way, remember we proved in the first video, or first part of this video, was e of x is now equal to n plus 1 over 2. Ta-da! That's snazzy, right? Now, not only do we get the expected value, we can also do it for the variance, all right? So now we're going to go ahead and do the variance. So that's what we're going to do now, is we're going to go ahead and find the variance. Now remember, variance is coming from working with the second derivative, okay? So what we're going to do is we're going to find the second derivative of t, okay? And so the second derivative of t, I'm looking back at my first derivative here, and I'm going to try to work from there. It's going to be 1 over n times, now I'm going to take the derivative, I'm going to take the derivative of the 1, which is going to be 0. Then I'm going to take the derivative of the 2t, which is just going to be 2. I'm going to take the derivative of the 3t squared, which is going to be 6t. Okay, the next term there would have been, what, 4t cubed, so I'll take the derivative of that. So that will be 12t squared. We're going to go all the way up to the last term, which would be n times n minus 1 times t to the n minus 2. All right? Now, from there, we do want to simplify that a little bit, just so that we can deal with it a little bit easier. Okay, we're going to turn it into a sigma, because there are just a lot of things going on there. Okay, so we're going to rewrite this as g double prime of t equals 1 over n. Now I am going to try to turn this into a summation. Okay, now I'm looking for a pattern. Sorry, I really should put in the 1 first, I guess. Let's go ahead and put the 1 in. So if I put the 1 in, then what I'm going to get is this, where I'm going to have 2 plus the t is 1, so that's 6 plus 12, all the way up to n times n minus 1, just like that. Now, every single one of these terms is n times n minus 1, right? This is 1 times 2. This is 2 times 3. This is 3 times 4. Every single one of those is n times n minus 1. So what we're going to do now is we are going to do what I mentioned before, and we're going to try to rewrite this as a sigma so that it'll be a little bit easier to work with. Okay, so we're going to go from I equals 1. Okay, so if I put in 1, then what am I going to need here, right? It's not going to be quite the same. It's going to be I times I plus 1, right? That right there is what I'm actually going to use, because that means if I put in 1 for I, I'll have 1 times 2. If I put in 2, then I'll have 2 times 3, all the way up. So if I put in a 1 here, right, if I put in my final term, I need to recognize if I put in n here, it's going to be n times n plus 1. So I'm actually not going to go up to n, I'm going to go all the way up to n minus 1. And so if I put n minus 1 in here, I'll get an n minus 1 there. And then when I put the n minus 1 in for I, it'll be n minus 1 plus 1, which will be n, which is exactly what I have right there. Okay? Now the reason why I'm putting this into sigma is because sigma is a little bit easier to work with, as you'll see. I'm going to rewrite this as the summation from I equals 1 to n minus 1. I'm going to distribute the I so that I have I squared plus I. So this is going to be of I squared plus, and again, the summation from I equals 1 to n minus 1 of I, just like that. Okay, now these two, if you'll look back to page 52, and I mentioned this a couple of videos ago, that there's several things on page 52 of your Hayes and Harris textbook that are things that this book kind of expects you to be able to use. If you need it on an IB exam, they'll give those things to you, those things that are on page 52 there. All right, so don't worry about memorizing them, but while you're doing your work, you need to kind of pay attention to things like this, where there is a simplified process on page 52 where they just give you the answer to this. What it ends up being is that g double prime of 1 will give us 1 over n, and then this first one turns to n times n minus 1 times 2n minus 1 all over 6, and then this one turns into n times n minus 1 all over 2, just like that. Okay, so from this point, okay, it looks like I've got some common terms there. I've got an n and an n minus 1. If I pull all of that out, right, the n times n minus 1, I'm going to leave the 2 temporarily because it's not super important at this point, but watch what happens. It becomes g double prime. Well, you can pull the 2 out if you want, but I'm going to have equals n times n minus 1 all over n. Okay, and then what would be left in here would be 2n minus 1 over 6 plus 1/2. Right? Now 1/2, of course, is the same thing as 3 over 6. Now that they have a common denominator, I can put them together, giving me that g double prime of 1 is equal to, look at that, those cancel out. n minus 1 times 2n minus 1 plus 3 plus 2 over 6. Now, if I put all that together, do the reductions, it doesn't matter when you divide by the 2, but I should then end up with g prime of 1 equals n minus 1, n plus 1. The 2 and the 6 will cancel out to give me 3, just like that. So now I've got g double prime of 1. Now we go back to what we found in the last video, right? Which was that the variance of x, almost there, friends. Remember that the second derivative is not the variance. The variance of x is g double prime of 1 plus g prime of 1 minus g prime of 1 squared. And that was what we ended up with at the end of the slide before this. I guess it wasn't the last video, it was this video. So let's go ahead and put those things in. So we've got the variance of x is equal to double prime of 1, so n minus 1, n plus 1, all over 3, plus g prime of 1, which we found was n plus 1 over 2, minus g prime of 1, which is n plus 1 over 2 squared. We've already proven that. From here, I'm going to let you go through the mathematics, find a common denominator, put things together, combine like terms, whatever you need to do at that point. You should be able to end up getting the final answer of variance of x equals n squared minus 1 over 12. I'm not going to go into those details because there's something to be said about you being able to do those final steps and getting what you're supposed to get at the end, and it's kind of exciting. So I'm not going to take that away from you. I'll let you go ahead and do that. All right, so go ahead, work through this, make sure you finish that up, and then you should be able to work some problems. Nice job, guys.